guys, Mrs. Brumwell here. Okay, we're gonna go through the 1.2 and 1.3 examples. Okay, so the first thing we wanna do, geometry is always dealing with figures. It's a great idea to draw a picture if you are not given a picture. So we're gonna read what's going on and then we're gonna try and draw a picture to go with these statements. Okay. So we have S, notice it's a capital letter, so I know that's a point. So they're saying point S is between points R and T. RS, so they didn't use a segment symbol or a line symbol, but remember anytime I use an equal sign, we don't use the segment symbol. So they're talking about a segment, the length of the segment, Rx, is given by this expression, 2x plus 7. Similarly, the length of the segment between S and T is 28. And the length from R to T is 4x. Find RT. So again, they didn't use the segment symbol, meaning they want me to find the length, a number, okay? All right, so we are going to set up a segment, right? We had a bunch of points, okay? We had 3. We had S, R, and T. So S is somewhere between R and T. So I'm going to put R and T as my ends. I'm not going to put S right in the middle because I don't want to confuse myself saying that it's a midpoint. It's just somewhere between. So I'm going to put it actually not in the middle intentionally and call that S. Okay, so they're saying R to S is 2x plus 7. So I'm going to put 2x plus 7 over that length. S to T is 28. And then R to T is 4x. So this whole length, R to T, is 4x. Okay, so in order for they want me to find the length of RT. Well, all I know right now is it's 4x. I want an actual number to go with RT, so I need to figure out what x is. So we're going to set up an equation and solve for x. Okay, so this has smaller parts of a segment, and we know that by the segment addition postulate, the two small parts have to add up to the whole thing. So that's going to be my equation. I'm going to add these two pieces. 2x plus 7 is the first piece, plus 28 has to equal the whole thing, which I know is 4x. Now, I said it already, but why I know I can do that is that's what the segment addition postulate says. Add the two small parts to equal the whole. So my justification for why I can set up this equation is the segment addition postulate. Okay. And now we're going to go ahead and finish this. I'm going to combine some like terms here. So 7 plus 20 is 35. So right now I've got 2x plus 35 equals 4x. I got to get my x's all together. So I'm going to subtract 2x to the other side. And we're left with 35 equals 2x. Divide by 2. Okay, so 35 divided by 2 is 17 and a half. So that's what I get for x. Now they asked me not to find x, they asked me to find RT. So RT was 4x. So we're going to go ahead and substitute 17.5 back in for x. So RT is 4 times 17.5, which if I do 4 times 17.5, I think we get 68. Nope, 70. All right. Oh, not 78, 70. There we go. Okay, so RT equals 70. Okay, another picture to set up for this one. We have L, so again, that's a point. L is in the interior, meaning inside. L is in the interior of angle JKM. And then they give me some measurements for some angles. Okay, so let's go ahead and draw an angle JKM. So K has to be the vertex because it's the middle letter. So I'm going to put J up here, M here. So we have JKM and JKL. Okay, so L is in the interior. So I'm going to put L somewhere inside. And then I'm actually going to use a ray to connect it just so I can easily see that there's two different angles here. So we are given the measure of angle JKL. So this angle right here is 56.4 degrees. Okay, and then the measure of JKM, so that's the whole thing. So this whole thing is 82.5. Find LKM. So they want me to find this one. I'm going to use X to represent that small angle. And I'm going to use two arcs to show it's different from this arc. Okay, so our equation is that these two smaller pieces have to add up to the whole thing. So 56.4 plus that unknown LKM has to equal 82.5. And that is very similar to what we did here. We used the segment addition postulate in number 1. This is just the angle addition postulate. Add the two small parts to equal the whole thing. Okay, so if I want to solve for x, all I have to do is subtract 56.4 from both sides. So if I do 82.5 minus 56.4, I get 26.1. So that is my solution for x. Okay, but again, they didn't ask for x, they asked for LKM. Oh, but actually I had x representing LKM, so I'm just going to write it out that the measurement of angle LKM is equal to 26.1 degrees. Okay, number 3. If ray BD bisects angle ABC, or that, not if, we have that, that's stated. And then if, and then they give me some measurements. So let's draw this setup right here. So we've got angle ABC, A, B must be the vertex, C, and then ray BD is bisecting. So it's cutting this angle exactly in half, and D is on here somewhere. Okay, so we're told the measure of angle ABD is 5y minus 3. So this one right here, 5y minus 3. And then angle DBC, that bottom one, is 3y plus 15. Find angle ABC, so that whole thing. Okay, well, if it's bisecting, you guys, we know that these two angles have to be the same, right? It's cutting it exactly in half, so either side of that ray must be equal. So we're going to set those two expressions equal. 5y minus 3 must equal 3y plus 15. And why I know those are equal is because of that word bisect. So this is the definition. It's what it means to bisect, right? It's cutting something in two equal halves. So we're going to say definition. And what are we cutting in half? We're cutting an angle in half. So I'm going to say the definition of an angle bisector. Okay, and then we're going to go ahead and finish this problem. So if I set those two equal, I'm going to rewrite my equation down here. So I've got 5y minus 3 equals 3y plus 15. So I'm going to subtract my 3y, and I'm going to add the 3. So I'm left with 5y minus 3y is 2y. Those cancel. And then 15 plus 3 is 18. Divide by 2, and we get y equals 9. Excuse me. Okay, so now they ask for this whole angle. So I'm going to plug y is 9 back in for one of these. So I'm just going to do 5 times 9 minus 3. But that's just going to give me this half. So what I need to do is then whatever I get for this, I'm going to multiply it by 2 to get the whole angle. So that's going to give me the angle ABC. Okay, so 5 times 9 is 45. Minus 3 is 42. 42 times 2 is 84. So we get the measure of angle ABC. Sorry, I keep breaking that. Is 84 degrees. Okay, last one here, guys. B is the midpoint of segment CD. Okay, so if we set that up as a picture, so we got segment CD. B is the midpoint, so we know that means exactly in the middle, and these two halves are congruent. Okay, CB, and actually, sorry guys, this one's gonna take me a hair more room, so I'm just gonna move this up just a little bit. Okay, I'm actually gonna do it right here. So we have CD, B is in the middle, these two are congruent. Okay, so C to B is 2x squared minus 8x. Okay, B to D is x squared minus 15. Find the value of C to B. All right, okay, well, let's go ahead and set up an equation to find x. So again, I already stated this, but we know those two segments are congruent, meaning those lengths must be equal to each other. So we've got 2x squared minus 8x equals x squared minus 15. Okay, so why do I know that those are equal? Well, because we were told b is the midpoint, and if it's exactly in the middle, the two halves are equal. So the key word for us was midpoint. So the definition of midpoint is how we knew to set those two segments equal. Okay, so let's go ahead and solve. So I'm seeing an x squared here, you guys, so I'm going to set it equal to 0 and then factor. So I'm going to subtract the x squared over. So here, I'll write this out. So we got 2x squared minus 8x equals x squared minus 15. So I'm going to subtract the x squared, and I'm going to add the 15 so that I have 0 on this side. So 2x squared minus 1x squared is x squared. I can't really do this subtraction. Those are not like terms, so I'm just going to write them next to each other. So I've got minus 8x and a positive 15, and then these all canceled on the right to give us 0. Okay, so now I want to factor. So I want numbers that multiply to be 15, multiply to be 15 that add to be negative 8. So numbers I can think of that multiply to be 15, 1 and 15, or 3 and 5. So 3 and 5 do add to be 8. But we want it to be negative 8, so I'm going to make them both negative, and then set it equal to 0. And then remember, the zero product property says set each factor equal to 0 and solve. So if I add 3, I get x equals 3, or add 5, we get x equals 3 or 5. Okay, so this asks us to find CB. Okay, so we are going to plug both of these in. If one of them gives us a negative number, that doesn't really make sense for a segment, right? Because we're actually talking about a length or a distance. It's not possible to have something negative. So we're going to check both of these by plugging both in. So I'm going to try 3 first. So I've got 2 times 3 squared minus 8 times 3. Okay, so I'm going to do the exponent first. So 9. 9 times 2 is 18. 8 times 3 is 24. Okay, so this one is not going to work because I'm going to get a negative number. So let's double check 5 real quick, and because that's what I need to answer this. So we're going to say 2 times 5 squared minus 8 times 5. 5 squared is 25, times 2 is 50. 8 times 5 is 40, so we get CB equals 10. So we do always get 2 solutions whenever I have a quadratic and it factors like this, but it's important to check both of them because a lot of times we might not get both of them to work. We want to take for, especially in geometry, if we're talking about a length or a measurement, it needs to be a positive measurement. So in this case, we had to use 5. Okay, that's it for these examples. Thanks for watching.